of variation. And if you remember, this is really just a linear thing, right? It looks a little like y equals mx plus b, except the b was 0 and the k is the same as the slope. Yeah. So now we're looking at what's called inverse variation. It's slightly different. Instead of y equals k times x, it's y equals k divided by x. So a slightly different model there. Constant of variation, k is the constant of variation in both. So it's that same kind of idea of there's a constant. One thing that's different about direct variation versus inverse. In direct variation, if one value is increasing, the other value is increasing. Or in the case of a negative constant of variation, if one is decreasing, so is the other. Now inverse, the word itself means opposite. So as one value gets bigger, the other one gets smaller. And think about here. As x gets bigger, it's in a denominator now. As the denominator gets bigger, the number itself gets what? Smaller. So that's what's happening. Same thing, and if your x gets smaller in the denominator, your number gets bigger. Can you have questions just for a moment? The number gets smaller. So it's kind of an opposite kind of change. So let's solve for k. And we've done this for direct variation. Remember y equals kx? How do I solve that for k? So I have k equals, what do? Divide each side by x. K equals y over x. Now I hope you remember when we did direct variation, we had to do this a number of times. Sometimes they give us 1 point. You find the constant of variation by doing y over x, and then you can find the general equation. Let's look at the difference for inverse. Here's my k. How do I solve that for k? What do?
Multiply y times x.
Multiply everything by x. Both sides by x, you're right. That will cancel them out. So k equals xy. So let's look at the difference. In direct variation, divide y divided by x. In inverse, you're actually multiplying the two xy, the x and the y, to get your constant. Do you have a question?
For the direct variation, like, if you have the k equals,
It is the slope, right? Change in y over change in x, because one of our points is 0, 0. So it's true. K is slope for direct variation. This is something else. So we'll look at what that thing looks like. But you're right, absolutely. So let's see, how can I tell, given an equation, if I have a direct or an inverse or neither? It doesn't have to be either of them. So one way we handled this the last time was solve it for y. And then compare. Compare with what? With these things. So for example, if I have xy equals -4, how do I solve that for y? What do I do? Divide each side by x, so I get y equals -4 over x. Does this look like y equals k times x? Does it? No. Does it look like y equals k over x? Yes. In this case, what's my k? So this is an inverse variation. Question?
Well, there are two. Now since a equals -4, that I think there's like I think about two. No, actually, there'd be four positive here. Two positive solutions for each.
I think that's it.
Oh, never mind.
All right. Y. I want to solve this one for y. How do I solve that for y? What do I do? What do I do?
multiply
By what?
by 2.
2. Because I want this to go away. You're absolutely right. If I do it to one side, I do it to the other. Y equals 2x. Direct inverse neither, which is this. What is it going to be? Back there, snap his fingers. What's it
Oh
going
no,
to be?
I was saying y equals 2.
Which is that direct, inverse?
Direct.
Direct.
Hold on.
Because what's the k? 2, right? Direct. Now what about this guy? Y equals 2x plus 3. Neither of them. How come? F plus 3. It looks a little bit like a direct, but direct variation always has the y-intercept of 0. So it's not either of them. So again, this is stuff we've done before. Solve it for y, decide if it's direct or inverse or neither. Compare it to the model function. Yeah?
Now, what is there? It's going to be a y equals 0.
Well, we're going to look at that. Hang on, we're going to look at that. All right, then let's do another comparison. So direct, y equals kx, inverse, y equals k over x, divided by x. To find k in a direct, y divided by x. To find k in an inverse, you multiply x times y. In direct, both variables are going to increase or both are going to decrease. With inverse, one gets bigger, the other gets smaller. Opposite. The graph is a line that goes through the origin. With direct, something like that. With inverse, we have this thing called a hyperbola. What's a hyperbola? We looked a little bit at it last time, what a hyperbola is. Remember we looked at conic sections, the parabola was this guy over here. If you slice through two cones, you get a parabola. So here's kind of what one looks like. An example of one. You get two branches. You get two branches.
That's for
Okay.
yeah.
Okay? Now what's interesting about hyperbolas is they have a new word here. They have asymptotes.
What?
I know. An asymptote, if you look what's going on here, see what's going on at this branch? What do you think's gonna happen? Picture you're all the way out in infinity land. You go all the way out there. What's this one doing? What do you think? It does keep getting flatter and flatter, but you know what it doesn't do? It never crosses the x-axis. The x-axis, hang on. The x-axis is an asymptote. It will get very close, but it won't go past it. Same thing here. As this gets closer and closer to 0 on the x-axis, it will not go past it. This also, it gets very close. Very close. Asymptotes are the lines that they can't cross. It's like brick walls. Like you had two brick walls here, and they kind of ricochet off, but they never quite touch it. I know it's hard to do. And you think about it, because it's 1 over x. Can I have x be 0? No, can I? No, since I'm averting my days here. I can't do that.
You can't divide by 0.
I can't divide by 0. Is that what you're going to say?
Yeah.
I can't do it. So if you have a function where a denominator can be 0, you're going to have an asymptote of some kind here. Or something has to happen that excludes it. So you get this kind of wacky thing here. So let's look at this graph now. I'm going to look at y equals 3 over x. That's here. The graph of an inverse variation is a hyperbola. Okay? It will never pass through the origin. Never. It can't. X can't be 0 because we always have an x in the denominator for an inverse variation. It never crosses either axis. It will never cross the x-axis. It will never cross the y-axis. And this is only hyperbolas of this form. We'll learn more about hyperbolas. Let's see, math analysis. Okay, what happens if k is negative? Let's just bring up a graph here. Oops. Let me get rid of that thing. So if I'm doing 3 divided by x, 3 divided by x, I'm going to make sure the bottom is off. I'm going to zoom standard so I can see what I got here. So that is y equals 3 over x. What happens if you have a negative k? Maybe with negative 3 as your constant of variation. I'm going to implement -2. So now I've got negative 3 over x. It actually flipped the branches. So if you have a positive k, you're going to be in quadrants 1 and 3. Oops. If you make this negative, you're going to branch into 2 and 4. So that's what the negative does. Yeah?
Is it possible to have a when they're like next to each other?
Yes. Yes, there are. Those will, I want to show you one like that. So let's look at graphs. For direct and inverse. Direct, I have a line going through 0. That's it, right? It passes through the origin. The constant variation is the slope. Now what's going on with inverse? I can have branches in quadrants 1 and 3, or branches in quadrants 2 and 4, but these are functions. So for inverse variation, they will always be a function. So I'm never going to have one input with more than one output. But can hyperbolas exist that way? Yes. But not if it's an inverse variation, it won't.
Yeah.
Question?
And also, I just realized the situation when you divide by 0, it won't be an undefined answer. It'll be like there's no answer at all for the situation.
Okay. All right, now let's look at the bottom of the page here. Can you tell from the graphs if they are direct variations, inverse variations, or neither? Let's look at this first one. Is this going to be direct, inverse, neither? Which one?
Correct.
Why?
I don't know.
Why? Why? It's a straight line going through the origin, so it will be a direct variation. How about this one? Direct, inverse, or neither, we said. How come? Quadrants 1 and 3, nice little function. How about this one? This is hyperbola too, what do you think?
What was the other one?
Direct, inverse, or neither, what's that one gonna be?
Inverse, because it's. No, no.
Not sure? What do you think? Not a function, right? Our variations, our direct variations, inverse variations are always a function. How do I know it's not a function? Well, look over here, this x has more than one y. In fact, there are a lot of x's with more than one y. Still hyperbola, but it's not a function. How about this guy? Direct, inverse, neither. What's it gonna be?
It's not just regular, it's a regular function.
It's just a line here. Why is it not a direct variation?
Because it doesn't go through the origin.
Doesn't go through the origin. Okay, so we can tell just by looking at the graphs what we have. Excellent. All right, let's look at how we kind of work with this. Now, this was very, very similar to what we did with direct variation. How can you tell if this table describes an inverse variation? Do you remember what we did? We had the same question with direct. How could I tell if it was direct or not? The idea was to see if you can calculate K. When we did this with an inverse direct variation, we said divide y over x. Remember doing that? And if you got the same number every time, it was direct. And I can tell by looking, especially here and here, I'm not going to get the same number if I divide. So for inverse, the K is x times y. What's negative 5 times 224? Negative 12. What's negative 3 times 4? 4 times negative 3. 8 times negative 1.5.
Wow, negative.
Negative 12. 24 times negative half. So is my K the same when I multiply the x and the y?
Yeah. Yes.
Yes. Okay, so I multiplied, I got the same value. Is this an inverse variation? Absolutely. What's K? And what's the equation? This was a kind of a mental block when we did direct variation. What is the equation?
Y equals.
Negative 12 over x. Right. And there was some problem with direct variation. We just had trouble writing the equation. The equation is very, very simple. You take the model for inverse is y is k over x. We found k, so you just plug it in. Oh, okay, that's all there is to it. And for some reason, this was really hard during direct variation. I hope now a little time has passed. We're like, oh, that's all there is to it. All right, moving right along, lightning speed. Yes.
What if they all match?
If nothing matched, then it would be neither. It would not be direct, it would not be inverse. And most things aren't, right? All right, so what's the summary? You get a table of values, and they ask you, is this direct? Is this inverse? Is it neither? The first test for direct would be divide y by x. Y divided by x for all of them. You get the same value? Direct. If you don't, try the next test. Inverse, you multiply the x and y. If you get the same value, great, it's an inverse. If not, it's not either of these things. So let's look at an example here. Kind of in the middle of the, top middle of the page on page 2. So let's see, is it direct, inverse, or neither? So should we try y over x?
Yeah.
Is that going to be the test for direct or inverse? Direct. What's 15 over 3? 25 over 5. 17.5 divided by 3.5.
Yes,
5. They're all the same.
Wow.
So what kind of a function are we looking at? This is direct. Now what's the equation that goes with this? What's the equation of this direct variation? What's going to be, Ashley? Excellent. Right? It's no big mystery. These equations, y equals kx is a direct variation. K is 5. Plug her in. I should see x's and y's. Let's look at this guy. I'm kind of just peeking ahead. try x times y. X times y, if all that comes out to be the same, what am I testing for here? Inverse. So negative 10 times 1.4. Negative 2 times negative 7. Negative 4. Negative 1 times 14. They're all the same. So is this direct inverse or neither? Inverse, because when I multiply them, I get the same number. What's my equation going to be? Yeah?
Y equals negative 14.
Excellent. Again, my model for this one is y equals k over x, so that k goes in the numerator, x goes in the denominator. So let's try this one. No, let's try y over x. I'll test for direct first. 5 over 10, well, that's a half. 8 over 16, that's a half. Oh, here we go. 2 over 8, 1/4. Right? What if I multiply them? That's 50. Oh, 16 times 8. I know it's not 50. 8 times 2, 6. Neither. Right? It didn't work either way. So that happens too. So you can tell by tables, dividing at y over x, that'll tell you if it's direct. Multiplying x or y tell you if it's inverse. Questions on that? Yeah.
So, if you were to do some time test, you had to figure out the direct inverse of the user, and you just plot them after.
I wouldn't plot them. I would do this. Y over x, x, y. You could plot them. But this, I think it's almost faster to just try. I would probably try multiplying first. Just because it's easier. For me, anyway, multiplying is easier. See if that works, doesn't work, try dividing, that doesn't work either. You could bracket. That's another option. All right, here's another kind of question you might see for direct variation. The variables x and y vary inversely. Now at this point, we know about 2 different kinds of variation. I always box them, circle them, do something. And when y is 6, x is negative 3. Write an inverse variation equation here. Well, how do I find k? What's k? K is x times y, right? X is negative 3. Y is 6. I'm getting negative 18 for k. So what's my equation? Oh, yes. Be very careful if you're doing inverse or if you're doing direct. You might want to get a highlighter out at some point because you just really got to think about that. Don't make those kinds of mistakes. Don't go quite to autopilot until you've done this a little bit. Find the value of y when x equals 4. That's easy. I have an equation. You just plug in the x. Negative 9 over 2 is fine. So once you have an equation, it's just like any other function, plugging values if you need to. And then, of course, word problems. Now, word problems, I think the directed inverse ones are actually pretty easy word problems to do. We know what to look for. Especially what we need to look for is how it's varying. So you definitely either want a highlighter, you want something that's going to say it's an inverse variation. And let's see what it says. They hire people to build a set. The work time, T, varies inversely. That's equals K over what? The number of people hired. So write that model. T equals K over P. For these, I tend to rewrite them as K. And I'll show you why in a moment. It makes this problem so much easier. K equals the multiplication of those two things. It says that 25 people work for 300 hours to do this job. So K, if you have 25 people, it takes 300 hours. So I can find K now. 25 times 300, 7,500? So that's K. So 7,500 equals P times T, or you can write it this way. However you want to do it, it's all equivalent. And then it says, find the work time per person if the company hires 30 people. Okay, well here's P. 7,500 equals 30 times T. So if I want to find T, divide by 30, and T equals, what's it be, 50 hours. So if you add more people, you save 50 hours, if that's what's going on here. I actually think the inverse ones are easier than the direct ones because you're multiplying. With the inverse, you had to divide correctly. You have to be really careful. You're multiplying. You could go either place, no problem. last question. The length of a violin string varies inversely. Okay, make sure that this is standing out, that we're doing an inverse variation, not direct, as the frequency. So let's see. Length varies inversely is K over the frequency. And you might want to write it as K equals L times F. The length times the frequency. They're going to give you one, right? A violin string that's 14 inches long vibrates at 450 cycles per second. So then I just multiply those. And that's my K. So coming back up here, I kind of have a model here, or you might want to write it this way. This might make it a little bit easier. It says find the frequency of a 12-inch violin string. So I know the length now is 12. That's enough. So divide by 12, divide by 12. 6,300 divided by 12. 525 seconds per second. And that's it. That is inverse variation. In a nutshell. Questions? This is a lot like what we did with the direct. I think it's actually a little bit easier. The homework has some direct, some inverse, so we're kind of reviewing both, so you'll get them both up to date. Any